The second part of this lecture is the learning outcome. At the end of the lesson, students should be able to compute the inverse of a non-singular matrix using the properties of A multiplied by B is equal to K multiplied by identity. This is really simple compared to the first method. Okay. Finding inverse by using the property of AB equal to KI. So let's say if A multiplied by B is equal to B multiplied by A, which is equal to I, then B is equal to A inverse, and A also can be equal to B inverse. How is it? Okay, so let's say AB is equal to I. So if we multiply all of this equation with A inverse from the left hand side, so here is A inverse. So this also we need to multiply with A inverse from the left hand side. Remember, multiplication between matrices is not commutative. So if we multiply from the left side, everything should be multiplied by the left side. So what is A inverse multiplied by A? Yes, it will be identity. So identity multiplied by B, and the right side, A inverse multiplied by identity will get A inverse. So I multiplied by B is equal to B itself, which is equal to A inverse. So vice versa. So if we multiply between two matrices and we get an identity or a multiple of identity, so they will be inverse of each other. Hence, if AB is equal to alpha of I, so a multiple of I, then A inverse equal to 1 over alpha of B, or, and also, not or, but and also B inverse equal to 1 over alpha of A. Note things. If AB is equal to I, where A and B are square matrices, then B is called the inverse of matrix A and written as A inverse. Thus, yes, A inverse equal to A inverse A equal to I. So we call it as identity matrix. I is identity. So let's do some example. Given that matrix A and matrix B, find A, B as a single matrix. So what we need to do is just multiply A and B. And then from the result, we need to deduce A inverse and B inverse. So they are not asking you to find what is A inverse, what is B inverse. They want you to deduce from the results. So let's find A, B first. So multiplication between two matrices. So we check first. How about the size or the order? So this one is 3 by 3. Matrix B also 3 by 3. So they are sekufu. And that means that we can multiply these two matrices. So what is the result? It should be a 3 by 3 matrix. Okay. What is the results for multiplication between these two matrices? So I don't have to show you. So we just have the results here. So for the first element, second element, and the third element. Okay. So let's fast forward for this one. So what is the result? We will get 5 0 0 0 5 0 0 0 5. So what is this matrix? So notice other elements from the leading diagonal is equal to 0. So we can call it as the multiple of identity. How to find the identity? We just have to take out the constant, the multiple of the leading diagonal of 1. So it will be a multiple of 5. So it is a 5i. So what is AB? AB is equal to 5i, a multiple of I. So deduce the A inverse and B inverse. So we know from the previous result AB is equal to 5i. Then, yes, directly we know that A inverse is equal to 1 over 5B. Remember, AB is equal to alpha I. Then A equal to 1 over alpha B. And B equal to A inverse equal to 1 over alpha B. B inverse equal to 1 over alpha A. Okay? So, what is A inverse? So, we just have to multiply 1 over 5 with B. So, multiply each element with 1 over 5. Okay? So, A inverse AB equal to A inverse of 5I. So, this part will be I. So, I of B is equal to B. Right? And then the right side, A inverse of I is equal to A inverse. So, what is A inverse? A inverse is equal to 1 over 5 B. So, what is B inverse? So, the same as the A inverse, it will be 1 over 5 A. So, just multiply the constant into the matrices. Don't leave like this. So, this is not the final answer yet. Okay. So, conclusion. So, we can use two methods to find the A inverse. The first one is to use the adjoint method, where adjoint is a cofactor transpose. And then we also know how to find the inverse by using adjoint method by using this formula 1 over determinant of A multiplied with adjoint A. Okay, the other method is to use the AB equal to KI property. So, please try to do this exam exercise. So, I'll give you the question and you can try, and then the answer is here. So, try for question number 2 and number 1 and number 2 and number 3. And then check whether you got it right or not. Okay, so that's all for this lecture. Thank you.